now we come to the topic of double hashing. In case of double hashing, we are using two hash functions. Obviously, that's why the name. There we are using two hash function here. H1 of k is the first hash function, H2 of k is the second hash function. But there is a catch. What is that catch? H1 of k is basically a primary hash function, and this primary hash function is first responsible for generating the hash value for a certain key k. Now, if this hash value that is generated by H1 of k does not produce a free slot, or there is a collision, or there occurs a collision, then only we are going to take the help of the second hash function. So now we have to understand the terms one by one. The H1 of k is equal to k mod m. If I assume that I am following the division hash function, then H1 of k is equal to k mod m, where m is basically the hash table size, or the size of the hash table, right? So now next hash function is H2 of k. So H2 of k is basically m1 minus k mod m1. So you have to keep in mind that m and m1, these two values should be selected with some criteria, right? The first is m will be supplied to you in question while you are solving problems. M1 might also be given to you in problems, but in some cases m1 will not be supplied to you, and in those cases what you have to do is that you have to select a value of m1 such a way such that m and m1 are prime to each other. Or we can say the GCD of m comma m1 is equal to 1, right? So m and m1 are either prime to each other, or the GCD of m comma m1 should be equal to 1. So apart from this particular condition, we have another condition for the second hash function, and there are basically two different conditions that it has to follow. The first one is the outcome or the hash value generated by H1 of k, H1, and the hash value generated by H2 should not be equal. So H1 should not be equal to H2. The second condition is H2 of k should not be equal to 0, and to actually maintain this condition, or to abide this condition, we have actually kept the formula as m1 minus k mod m1. Now there may be a confusion that why we have subtracted k mod m1 from m1. I will take a small example, right? If I consider this as 14, m to be as 11, and m1 to be as 7. So our condition was GCD of m comma m1 should be equal to 1. So obviously 7 and 11 are prime to each other, and the GCD is also equal to 1. Now, if I consider, now I is varying from 0 to m minus 1. So if I put I equal to 0, then this particular term completely vanishes, right? So we are left with only H1 of k. So first we will check what we are getting from H1 of k. We are getting 14 mod 11 equal to 3. And if I say that third location is already occupied by some data value, then this particular thing is a collision. Now, if for the timing I say that this particular part is not present in this equation, then we are only left with H2 of k equal to k mod m1. And in this case, if I put 14 over here, right? So when I'm using second hash function, that means I am incrementing the value of I by 1. Previously the value of I was 0, and from that when the value of I was 0, I got H1 of k as 3, which was a collision. Now in order to resolve collision, I'm now using double hashing. I'm now taking the advantage of second hash function. To take the advantage of second hash function, we will increase the value of I by 1. So now the value of I is basically 1. Right, and the key value is 14. So now what happens, the value of I over here becomes 1, and now since this part is not considered to be a part of the equation, so we are left with 14 mod 7, which is equal to 0. Now see very carefully. So if I apply 14 comma 1 over here, then H1 of k, it is already obtained, it's 3, right? And 1 into H2 of k is 0. So 3 plus 0 gives you 3 itself. So 3 mod 11 gives you again 3, right? So do you think any productive outcome you have got? No, because H1 of k has already produced an outcome of 3, right? When I was equal to 0, H1 of k has already produced an outcome of 3, and when I is incremented to 1, with the help of H2, I cannot even get a productive value. I'm generating the same hash value again. Which is 3. And when I'm generating the same hash value again, I'm basically violating two conditions. The first one is h1 should not be equal to h2. This is violated, as well as h2 of k not equal to 0. 14 mod m1 is equal to 0, so this is also violated. So these two conditions are provided so that such kind of non-productive outcome should not happen. If you are taking the help of the second hash function, and by adding the first and the second hash function, we are getting a value which has already been generated previously by h1 of k, then the productive outcome is nothing. So to avoid that, we are basically subtracting k mod m1 from m1. So in this particular case, this will be 7, and the outcome will not be 0, it will be 7. And in that case, this outcome will be 7. So 3 plus 7 is 10. So 10 mod 11 will be 10 again. If this is difficult to understand, don't worry. We will go to the example section and we will take a series of key values and understand how the key values are inserted into the hash table. So now we consider a double hashing example. So in this double hashing example, if you see, there are a lot of keys that we have to insert into the hashing table of size 11. And the hash function that we are going to use is division hash function. And obviously, if there is any collision, we are going to resolve that collision using double hashing, right? So the double hashing formula, the equation is given over here. And h1k is what? h1k is k mod 11. Value of m1 in h2 of k has to be selected wisely so that m1 and m both are prime to each other. So m and m1 are prime to each other over here because we have taken because m is already supplied with 11 and we have taken m1 to be 7. You can take any other value as well, but you have to keep in mind that the GCD of these two values should be equal to 1, or they should be prime to each other, right? So if h1k is expanded like k mod 11, and h2 of k is expanded as 7 minus k mod 7, right? So now we are going to insert these key values into the hash table one by one. So now we'll start with 58, right? So 58 means h of 58 comma 0. We have to start I with 0, right? When we start I with 0, automatically this term vanishes. So only we are left with h1 of k. So h1 of k means it's k mod 11. So k is what? 58. So 58 mod 11 mod 11. This is what we get. And the result is obviously 3. So we have to check whether 3 is empty or not. Yes, it is. So if 3 is empty, we insert 58 in third index of the hash table, right? Now we move on to 14. So again for 14 also, we will put I equal to 0, and 14 mod 11 is 3. So 3 mod 11 is again 3. So again for 3 it is collision, right? So since there is a collision over here, we have to increment the value of I by 1, okay? So that the second hash function comes into action, right? So h1 of k, we have already obtained h1 of k as 3. So we'll write 3 over here plus. Now what is h2 of k? h2 of k is 7 minus. So I is what over here? I is 1. So 1 into something will give you that particular value itself. So we are not writing 1 over here, right? We are directly expanding h2 of k. So it is 7 minus. K is basically what? K is 14. So 14 mod 7 mod 11, right? So what is the value? 3 plus 7 minus 14 when divided with 7, we get a remainder of 0. So 7 minus 0 gives you 7. So 3 plus 7 is 10. 10 mod 11 is basically what? 10, right? 10 mod 11 is basically what? It's 10. So if it is 10, then we'll check whether 10 is empty or not. Yes, it is. So we'll insert 14 into that index location, right? So now we move on to the next value. So when we move on to the next value over here is 91. So 91 mod 11. 91 mod 11. 91 mod 11 means it's again 3, right? So if it is 3, that means again there is a collision. So when there is a collision, we will take the help of the second hash function by incrementing the value of I by 1. So when we do that, we get 91. H1 of k we have got 3. So 3 plus, we expand this one. So the value of I is now 1. So we are not writing 1 over here. We are directly expanding H2. So it is basically 7 minus k is 91. 91 mod 7 mod 11, which is 3 plus 91 mod 7 is 7 minus 0 mod 11, right? So this particular value gives you 10 mod 11, which is again 10. But 10 is already occupied by 14. So obviously we are not going to take 10. So we are now going to increment the value of I by 1, which now comes out to be 2, right? So obviously the value of H1k will not change. Now the value of I is 2. So we have to multiply the entire product by 2. And the H2 of k is also unchanged because there is no change. Only change is the value of I is incremented, right? So what happens? 91 mod 7 is basically 0. So 7 minus 0 gives you 7. So 7 into 2 gives you 14. So what we get is 3 plus 14 mod 11. So 14 plus 3 is 17. So 17 means it's 6th location, right? So 6th location is empty. Yes, it is. So what we do is we insert 91 into 6th location, right? So now we move on to 25. 25 mod 11 is again 3. Okay. So again there is a collision, right? So again now we have to take the help of second hash function by incrementing the value of 1, by incrementing the value of I by 1. So h1 of k over here is 3 plus I is 1, so we are not putting the value of I over here in this pass. So we are keeping it as 7 minus k is basically 25 mod 7 mod 11, right? This is what it is. So it should be equal to 3 plus 7, 25 mod 7 is 4. 7 minus 4 mod 11, which is 3 plus 7 minus 4 is 3, 3 plus 3 is 6. 6 mod 11, which is equal to 6 mod 11 is equal to 6. But 6 is already occupied by 91, so there is again a collision. So we have to increase the value of I by 1, which now becomes 2. So again h1 of k remains unchanged, h2 of k also remains unchanged, only the value of I now becomes 2, right? So we have to multiply the entire value of h2k by 2, right? So we are putting just 2 over here, and the resultant outcome changes by, this is 7 minus 4 is 3, so 2 into 3 is 6, 6 plus 3 is 9, 6 plus 3 is 9, so 9 mod 11 will give you 9. So we have to check whether 9th location is empty or not. Yes, it is. So we will put 25 over in 9th location. So in this way, we can easily insert elements into the hash table using double hashing. Right? Now we move on to the next topic, which is rehashing. Now what is rehashing? Rehashing is a kind of technique which is only applied when the present hash table is almost filled with many different key values, right? And when the present hash table is almost filled now with new key values, the number of collision will increase. The number of collision will increase. So in order to reduce the number of collisions, one solution is rehashing. What is rehashing? If I consider the present hash table to consist of m1 different locations, right? m1 different locations, then if it is almost or complete or almost filled, then I will consider taking another hash table which is double the size of the original hash table. So if this is 0, this is 2m1 minus 1, right? So there are a total of 2m1 different locations. Now, when you actually create the new hash table, all the entries that were in the previous hash table have to be mapped again from the beginning into the new hash table, right? So obviously if division method was actually used as a hash function, then in this case it would be hk equals to k mod m1, right? It was for this one, right? Now when we have doubled the size of m1, the new hash function h prime of k will then be equals to k mod 2m1, right? So this is what will be the next one. So all the entries that were made into this hash table has to be again mapped using this hash function, right? Again for this hash table. And then you have to take out all the entries from the previous hash table and map it again from the beginning into this new hash table using the new hash function. Okay, so this is what is rehashing.